This example is calculating a molecular formula from percent data along with a molar mass. We said that we've always got to be given a molar mass and at least enough information to calculate an empirical formula. Well, we have that. We've calculated empirical formulas from percent data before. Unfortunately, this makes the problem a little longer, but it is what it is. So let's go ahead and get started. In order to do this, the very first thing we're going to need to do is calculate the empirical formula because we don't have it. Then we can go ahead and use that molar mass that we're given in order to calculate N and get to our molecular formula. So let's go ahead and get started with the empirical formula. The very first thing we want to do is convert percent to grams, and we've said that's pretty easy because all we're going to do is write down 40.0, and rather than write down the percent, we're going to write down grams of carbon, and then we've got 6.67 grams of hydrogen and 53.3 grams of oxygen. So that is converting percent to grams. The next thing we're going to do is we're going to convert those grams to moles. So we go times, times. Got 1 mole of carbon, 1 mole of hydrogen, and 1 mole of oxygen. On the bottom, we're going to put our molar masses, which we'll get from the periodic table. Just a little refresher. Periodic table, there we go. We've got carbon, we've got oxygen, and we've got hydrogen. So for carbon, it's 12.01 grams. For hydrogen, we're always going to use 1.008 grams. And for oxygen, we're looking at 16.00 grams of oxygen. So my grams will cancel. That'll leave me with moles. I'm going to go ahead and grab a calculator in a second here. So let's see here. Slide this over and turn that on. We've got 40.0 divided by 12.01 equals 3.33. We're looking at 3 sig figs, so it's 3.33. 3.33 moles of carbon. Let's go ahead and do our hydrogen. We've got 6.67 divided by 1.008. That gives us 6.617, but we only need 3 sig figs, so that 1 becomes a 2. So we've got 6.62 moles of carbon. And then last but not least, we've got 53.3 grams divided by 16.00 grams. And we get, again, 3.331. We're looking at 3 sig figs, so it's 3.33. 3.33 moles of carbon. So we've completed our grams to moles step. First step, second step. Next step is to divide by the smallest number of moles. So taking a look at these, it's a tie for the smallest number of moles, 3.33 moles of carbon and 3.33 moles of oxygen. And I think I mislabeled something here. This should be, oops, this should be hydrogen. There we go. All right, so I'm going to divide everything by 3.33 because it's a tie for the lowest. So that's going to be divided by 3.33. That gives us 1. This is going to be divided by 3.33, which I'll calculate in a second. Let's do the easy ones first. 3.33 is going to be equal to 1. So let me grab a calculator here, and I've got 6.62 divided by 3.33 is going to be equal to 1.987. We're looking at 3 sig figs, so the 7 makes the 8 a 9. So let's go ahead and make that 1.99. which is approximately 2. As we've discussed in class, if we're less than a tenth away, less than a tenth, meaning like in this case we're 0.01 away from 2, we can go ahead and round to 2. So that's what we did. So we've got dividing by the smallest. We went ahead and did that. For our third step along the way to empirical formula, we're now ready to go ahead and write our empirical formula. So we've got an empirical formula of CH2O. That is our empirical formula. Step 5 would be to multiply by some number to eliminate any decimals. We don't have any decimals, so we don't have to do step 5. So let's go ahead and work on the molecular formula then. In order to calculate the molecular formula, we know that the molecular formula is going to be equal to n times the empirical formula, which we now have. Problem is, we don't have n. So n, we know, is going to be the molar mass divided by the empirical mass. Let's go ahead and take that over here. N is going to be equal to, well, the molar mass, we identified that up here. So we can go ahead and take that 150.0 grams and put that there, divided by our empirical mass, which we don't have. We're going to have to calculate that. So let's go over to the side here and calculate that empirical mass. I've got carbon, that's going to be 1 times 12.01. I'm going to run out of room there. Let me move that over a little bit. So I've got 1 times, for carbon, I've got 1 times 12.01, which is going to be equal to 12.01 grams. And then for hydrogen, I've got 2 times 1.008, which is going to be equal to 2.016 grams. And then for oxygen, it's going to be 1 times 16.00, which is going to be equal to 16.00. I add these guys up, and I get 620. That's going to be 10. Carry that. That's going to be 30.026 grams. So that is my empirical mass. Okay, so that's my empirical mass calculation there. And that 30.026 goes down here, 30.026, again, grams. So we get an N of, let's go ahead and get a calculator here. Drag that over there. And we've got 150.0 divided by 30.026. Grams cancel. I get 4.995. I'm looking at 4 sig figs here. All that 4.995 becomes 4.996 because I had a 6 after that 5. That makes that round up. We're definitely less than a tenth away, so this is going to be approximately 5. So n is 5. We're now ready to go ahead and calculate our empirical formula. So that, excuse me, molecular formula. That molecular formula is going to be equal to n, which we just figured out as 5, times our empirical formula, which is CH2O. We distribute that 5 through, and we're going to get C5H10O5. So this is my molecular formula, which we were asked for right here. And we were asked to calculate the empirical formula, so let me go ahead and identify that also. The empirical formula is up here as my empirical formula. There we go. A little longer because we had to calculate our own empirical formula. But if you're given percentages, you just have to do that.